Hi everyone, I hope you're okay. This is video number 5. Video number 5, guys, of me tackling the physical science paper 2 rather. Please note that there are 4 videos before this one, and there will be 4 videos after this one. Just click the link on the description, go to the playlist whereby I start from question 1 until the 9th question. Do the questions with me. If there are things I'm not sure about, please do ask on the comment section. I'll definitely come back to you. Okay, we are told that the reaction between excess dilute hydrochloric acid and sodium thiosulfate is used to investigate the factors that influence reaction rate. There are 5 factors that influence reaction rate, right? We have the concentration, number 1. We have pressure of gases, we have temperature, we have a catalyst, and we have the state of division or surface area. There is the 6th one, but they hardly ask about it nowadays. It's the nature of reactants. Are you together? So just focus on the first 5, you'll be okay. We are given the reaction between sodium thiosulfate and the hydrochloric acid. Obviously, it produces sodium chloride, sulfur, water, and sulfur dioxide. Okay, and then we are told that the concentration of hydrochloric acid used is 1 mole per cubic decimeters. The same volume of hydrochloric acid is used in each run. Okay, and then we are told that the time taken for the cross on the paper under the flask to become invisible is measured. Okay, we are being shown the apparatus there, and then there are 3 runs that were made for this investigation. In the first run, they used 50 cubic centimeters of sodium thiosulfate, and then in reaction 2 and 3 they diluted the sodium thiosulfate together by adding water. So basically, whenever you dilute something, you are tampering with its concentration. You are decreasing its concentration. Are you together? Okay. So now, I can simply conclude that the factor which was measured here was concentration of my sodium thiosulfate. Are you together? So the first question says I must define the rate of reaction. So the rate of reaction can be defined as the change in the quantity of product per unit time. The quantity, you can simply say the change in mass per unit time, the change in number of moles, or the change in concentration is up to you. Are you together? The change in the quantity of products or reactants per unit time. But you can substitute the term quantity with concentration, mass, and number of moles. It's up to you. Okay. Then 5.2, you are supposed to write down the independent variable. Okay, the independent variable in this case is the one that they keep on changing. Remember that we are only focusing on the factors that influence the reaction rate. So I know that whenever they dilute my my sodium thiosulfate, they are tampering with its concentration. So my independent variable is my concentration. Are you together? So concentration is my independent variable. Okay, so now I'm told to calculate P in the table. How can I do that? P, I know that is the concentration of my sodium thiosulfate after it has been diluted by 20 cubic centimeters of water. Are you together? But remember that they are just using the same sodium thiosulfate, but now with a lower volume. Instead of using the total volume of 50 cubic centimeters of my sodium thiosulfate, they will take 30 cubic centimeters, and then they will add the other 20 with water. So I know that in this dilution that happens, the number of moles of my sodium thiosulfate will just remain the same. Are you together? So for the number of moles of my pure sodium thiosulfate, I know that concentration is N over V, right? The concentration, initially the concentration of my sodium thiosulfate without water being added is 0.13. Are you together? And my volume in reaction 3, I've only used 30 cubic centimeters. So I just need to change the 30 cubic centimeters into cubic decimeters. So this will be 0.03. So the number of moles, I will have 0.03 multiplied by 0.13. So my number of moles, I have 0.0039 moles. Are you together? So these are the number of moles of my sodium thiosulfate. And then I had this number of moles, and then they diluted my sodium thiosulfate. Whenever they dilute it, my concentration will go down. It will decrease. Are you together? But the number of moles are still there. So now I just want the new concentration after the dilution of my sodium thiosulfate. The number of moles is 0.0039. The volume now is no longer 30 cubic centimeters. It's the combination of 30 cubic centimeters and 20. I have 0.05. So I'll just divide this by 0.05. I'll simply get 0.078 mole per cubic decimeter. So P is just equal to 0.078. P is just equal to 0.78 mole per cubic decimeters. Okay, and then now we are told that when 21 grams of sulfur has formed in run 1, the cross becomes invisible. Calculate the average reaction rate that will calculate the average reaction rate with respect to sodium thiosulfate in grams per mole. So they want us to find the rate of reaction in grams per mole. No? So basically what we need to do, the first thing we need to do is to find the number of moles of sulfur which was formed. The number of moles of sulfur. How can we do that? We are given the mass there, that our mass is 0.21 grams. So the number of moles for sulfur is mass all over the relative atomic mass number. The mass is 0.21, and then the atomic mass number, we have our sulfur is equal to 32. I'll just divide this by 32. 0.21 divided by 32. This will give me 0.0065. I don't want to round off, 0.06525 moles. 0.0625 moles. What do I know? I know that the ratio between my sodium thiosulfate and my sulfur is 1:1. So which simply means that the number of moles which I used to create this amount of sulfur, the number of moles of sodium thiosulfate which were used will also be equal to 0.00652 moles. Are you together? So all I need to do is to calculate the amount of mass which was used, because these are the number of moles, right? How can I find the amount of mass which I used? Remember that number of moles is equal to mass all over the molar mass. Are you together? So therefore my mass will be number of moles times the molar mass. my molar mass for sodium thiosulfate, I simply have the sodium is 23, but I have 2 of them. Sulfur is 32, I have 2 of them. And then oxygen, I have 3. It's 16, but I have 3 of them. Ne? So the molar mass is 158 grams per mole altogether. So for me to find the mass of the sodium thiosulfate which was used, I just need to take 158, which is my molar mass, multiplied by the number of moles, which is 0.0065625. Just multiply this by 158. I'll simply get my mass to be 1.04 grams altogether. So this was the mass which was used to form, to form sulfur altogether. So for me to find the rate of reaction, the rate of reaction will be just the change in mass all over the change in time. Why am I using change in mass? Because I'm supposed to find the rate of reaction in grams per second. That means I must use the change in mass, right? The change in mass basically is the amount of mass which was used. So in this case, I know that I have 1.04 divided by the time it took for reaction 1, it's 20.4 seconds. So my reaction rate is 1.04 divided by 20.4. So this will give me 0.051 grams per second. This is my rate of reaction. The rate of reaction is 0.051 grams per second. Okay, let me write it there. 0.051 grams per second. Okay, another investigation is performed at a different temperature. Sketch the Maxwell-Boltzmann distribution curve for the reaction at 20 degrees. Label this curve as A. On the same set of axes, draw the curve that will be obtained at 35 degrees. Label it to curve B. Ne? If this is our Maxwell-Boltzmann distribution curve, the first reaction will be like this one. This one will represent curve A, ne? And then at a higher temperature, this one will represent to curve B. Altogether, obviously you must label your axes and then write the heading that this is a Maxwell distribution curve. Okay, and then now they want us to explain the effect of temperature on the reaction rate in terms of collision theory. Please note that whenever you increase temperature, more particles will move faster, and hence they will have more kinetic energy. So therefore, the sufficient kinetic energy will then result in more effective collisions, and hence there will be a greater reaction rate. That's how, guys, you should have answered question number 5. I hope this was fruitful, guys. If you are not happy or there are things you're not sure about, please do comment. I'll definitely come back to you. Thank you very much.